Hi, welcome to my channel. In our last video, we have seen that how we can form derived functions to generate and execute SQL queries with multiple query parameters. These functions are powerful enough to handle simple queries, but not good for complex queries. Moreover, the function name becomes difficult to read when it gets really long. So to handle such complexities, Spring JPA provides us two ways. Either we can write JPQL queries or we can write native SQL queries. So today's video is all about these two types of queries, and we will discuss pros and cons of both of them while seeing them in action. So without any delay, let's get started. First, we are going to talk about JPQL. For most of the developers, it comes first in priority because of few reasons. Like in JPQL, we write our query according to our entity's definitions, right? Because in JPQL, we write queries to retrieve data through our entity object instead of directly from the table. So every JPQL is processed and executed by our JPA implementation, which is kind of beneficial because the JPA is capable to handle different database dialects, right? So in case, suppose if you want to change the database server in the middle of your project, for example, migrating from MySQL database to PostgreSQL database, you can easily do that without making any changes to your JPQL queries. And through JPQL, we can actually forbid the accidental access to the table columns that we do not want to share with our application. For example, I have this country table here, and I have these four columns in this country table, right? And let's assume this project is one of the microservices we have, and I do not want this microservice to see this GDP data of the countries, right? And I can do that by simply not defining that GDP column in our entity class. And since the definition is not here, you cannot access data in that column through JPQL or even derived queries. Let's see some example of JPQL, and then we will talk about one of the drawbacks of JPQL queries. This is our country repository, and let's replicate the result of this function find by ID, but this time by using JPQL query. Create a function country, let's say get by ID, int ID. Okay, now we need to annotate this function with @query annotation. Okay, and inside this we need to pass our JPQL query. So if you want to select all columns of your entity class, then you can simply write from, then your entity name, say country, where ID equal to $1. JPA will replace this $1 with the first parameter of this function. Okay, and this function will return the data of country matching with the ID that we are going to pass here. It will return the data of ID, country name, and population, but will not return the column GDP. Okay, so let's create one endpoint to access data through this function. Let's say get country, and here get country request param. We will pass the ID of the country that we want. Okay, and we will create one method inside our service class, which is get country. Okay, so let's create this method, save these files, and in city service let's return country repository dot get by ID, right? And we need to return a single object of country. Save this and run this application. Go to Postman and let's say localhost 8080 slash get country, and we need to pass one parameter which is ID. Hit send and we are getting the data of Algeria. Okay, and as we were expecting, the GDP data is not here, right? So let's see one more example here, and let's this time replicate this function. Okay, so list country, and let's say get by country name. We really do not need to care about the method naming convention here while writing JPQL or native SQL query, as we were doing in case of the derived functions. Okay, so let's pass this parameter prefix and now annotate this function with @query annotation. We can also use alias name to select all columns from our country entity class, and for that we need to write select C from country C, where C dot country name for starts with we need to use keyword like and question mark 1. It should start with the prefix, and we really don't care about what is after that, and for that we need to put this percentage sign. Okay, now the next part is order by population in ascending order. For that, just say order by C dot population ASC for ascending order, right? Let's create one more endpoint here. Say get country by name. In a request parameter, we are expecting user to pass the country name. Let's say prefix, and we are passing prefix to this function which is not there yet, so we will create that, and country repository dot get country name. Okay, and we are passing the prefix here, and of course the return type is list of countries. Same we need to do here, list of countries. Now run the application. And just hit this endpoint, get country name, and here we need to pass the prefix of country that we want. Okay, so we need to pass prefix, let's say A, send it. Okay, we got all countries starting with letter A, order by population in ascending order, right? Now let's see one more example here. Let's create one more function here, a list of country, get by CNAME and population, and here let's pass the country name and population as well. Annotate it with @query annotation, and let's say select C from country C, where C dot country name like country name percentage and C dot population is greater than equal to. Okay, now there are two ways to bind parameters with your query. One way, what we were doing here, is called bind by position. Okay, question mark 1 refers to the first parameter of the function. Now here we are binding it by its name. Okay, and for that we need to prefix our parameter name with this column, and also we need to annotate our parameter with @param annotation. And inside this we need to pass the name of our parameter, like country name, and for this let's say population. I personally prefer this way because this approach is more readable. So let's create one more endpoint in our home controller and pop and pop string, let's say prefix, and request param long population. Pop prefix and population. Okay, now let's create this function. Country repository dot get cname and population, say prefix. Now run this application. We need to hit this endpoint this time, and we need to pass one more parameter here, which is population, and let's say population should be greater than 200,000. Okay, hit send, and we got all countries starting with letter A, and population is greater than 200,000. Okay, now let's suppose we want these country name and population column in result, but we do not want to include this ID column. So let's do that. Here in your country repository, just select c.country name and c.population. Although it is not showing any error here, but if we try to run and execute this query, JPA will fail to map the result into this return type because we are missing the ID field here, which is required in this entity. So to do that, we can simply replace this return type with either a Pojo class with custom columns, or we can simply return the array of object. Change the return types in city service and home control as well. Save this, run the application, copy this, paste it here. Now click send. Okay, we got array of arrays as a result, but this time without ID. Now let's talk about a drawback of JPQL. JPQL supports only the subset of standard SQL. Okay, so if we want to write complex queries, for example with multiple joins, nested queries and function callings, etc., we should write native SQL queries instead. So let's see how to write native SQL query on JPA repository. The main advantage of native query is that it is not processed by the JPA implementation, and it will directly send to the database server for execution. And in native queries, instead of querying our entity class, we directly query the database table. So in this case, we can access data from all columns of the table without any restriction. Now let's see some example of native SQL query. Copy this function, paste it here. We are going to replicate the result of this function, and to change this JPQL query to native query, we just need to make some slight changes. Let's first get rid of this error, and then inside this query annotation we need to pass this whole SQL script in a parameter called value, and we need to set one more parameter here, which is native query is equal to true. Okay, now the third thing that we need to do is change this entity name to our table name, because in native query we do not query our entity class for data, we query the database table instead. Okay, so country is here, and instead of member variable name here, we need to pass the table column name, country name, country name here, population here. Okay, save it, copy this function name, go to city service and change this function name to this one, and that's it. Run this application, copy this, paste it here, click on send, and we are getting the same data, right? So these are the only changes that you need to do to convert your JPQL into native SQL query, right? As I said before, native queries are not processed by the JPA implementation, and we can access data from any column of the table. It really doesn't matter you have that column definition in your entity class or not. Like in our previous example, we have seen that we were not able to access the GDP data, but using native query, we can easily do that. We just need to add that column in our query. Let's say c.gdp, save it, run it again, send it, and this is our GDP data, right? You can write whatever SQL query that you want to submit on your database server. If you want to fetch data from multiple tables, we can write also join query here. For example, let's say I have one more table here, which is cities, and I have these data in my cities table, right? So let's fetch the data from city name column along with these data. Okay, so left join cities city on c dot country id equal to city dot country id, and let's fetch the city name column here, city dot city name. Save this. Now run the application, and let's fetch data of, let's say, United States. Okay, send it. Now we are also getting city's name along with the country data. Okay, although this approach seems pretty comfortable, but it has a drawback. Suppose if you want to change your database server, for example, in our case, if you want to move from PostgreSQL to MySQL, we may need to change all native queries that we have in our project, because in that case, we need to change our PostgreSQL dialect that we are using in our project to MySQL dialect. And every database server has its own standard of SQL, and we need to modify our query to match that standard, right? So these are the simple example of JPQL and native SQL query. Now what if we want to fetch records of multiple countries matching with the set of ID instead of single ID? In that case, we can use the in keyword. This in keyword is same for JPQL and native SQL query. We just need to make slight changes. Here, instead of equal to, write in, and let's change this method name to IDs. It will return list of country, and we need to pass set of integer here instead of single ID. Okay, save this. Now let's create one method here in our service class as well. List of country, get country by IDs. We need to pass set of integer here, IDs, and change this name to get by IDs. Okay, now create one endpoint here, get country by IDs, change method name to by IDs, return type to list of country, and instead of request param, let's say we are going to pass request body, set integer IDs, get country by IDs. Now save this, run the application, go to Postman. Now let's create a request. We need to hit this endpoint, remove this. Now in body param, we need to pass a JSON of set of IDs. Let's say 1, 5, 7, 10, 15. Okay, hit send and we got the data, right? So this is how we can write JPQL and native SQL query in Spring Data JPA. We will do some complex queries in JPQL and native SQL queries in our future videos, but by that time, do some exercises and try to write some complex queries by yourself. So this is it for this video. If you like this video, please hit that like button and subscribe to my channel. Thanks for watching. Bye bye. Take care.